Hi, Randy Barnett for Fluke. With 35 years of experience as an electrician, I've become a power quality expert and electrical trainer. In this video, we're going to talk about power factor. Have you ever talked to your clients about power factor? Could be costing them a lot of money every month. Nobody knows better than you whether or not they probably have a power factor problem. I'm going to show you how to go in and conduct a power quality survey and help them find that power factor issue and save money. Some of the steps we will take today to help you keep your utility bill low by using power factor checks are: review utility bills, check your utility meter, connect the power logger, log for up to 1 week, check for kW, kWh, and power factor, and last, evaluate your power factor and mitigate if necessary. This is how much you can save every month if you use the Fluke 1735 power logger to monitor and manage power factor in your facility. Power factor is a measure of how much electrical energy you are wasting, typically from the effects of creating magnetic fields, such as in motors and transformers. Most utilities prefer that you keep your power factor values as high as, say, 0.92 or 0.95 or even better. Start your power factor survey at the utility meter. If you're being charged for power factor, their meter should have a power factor readout function. When observing the meter, be sure to record the meter number. Some other indications you can expect to see include kW, kVARs, and timestamp information used for time of day billing. When you are working with voltages of greater than 50 volts, it is extremely important to use the proper personnel protective equipment, or PPE. The PPE you choose should be based on the arc flash warning label found on the equipment, or the tables in NFPA 70E. To remove a cover downstream of the 480 volt breaker, this worker has chosen hazard risk category 4 clothing and class 0 voltage rated gloves. Connecting at the service is tricky. Make sure you are using your voltage rated tools. Here you can see inside the main cover to show you exactly how connections are made. When you do this, you will most likely be lying on your back in your flash suit and wearing gloves reaching up to connect, as you see here. In addition to making sure all test leads are applied to the correct phases, make sure the arrows on the current clamps point towards the load. If not, your power factor readings may be drastically inaccurate. Once you finish connecting, always make sure to check your setup and verify that connections are correctly made. When you're preparing to leave a logger behind for an extended time period, you want to make sure you're capturing the correct data. You can check this by turning the dial on the Fluke 1735 power logger to meter. The Fluke 1735 power logger automatically captures all of the major power parameters while it logs. In this case, we're focused mostly on power factor. Start recording and walk away. You want to capture the full demand cycle if at all possible, in particular, a full average 7-day week. You will get the best information if you can document the state of the power supply under all of the different operating conditions that occur in the facility. When you're done logging, come back, terminate the recording, and check the data on your logger to verify you collected the data you wanted. Review kW, kVA, kVAR, and most importantly, power factor. A decent power factor value is usually 0.9 and above, but it depends on the utility. If power factor is bad, but power demand is low, the utility probably won't charge for it, and it's not worth fixing. If you have bad power factor and high demand, your next step is to find the problem load. Most often, bad power factor is caused by big motors, welders, compressors, or loads that are constantly on, like lighting, especially high-efficiency lighting. Identify culprits and log power factor at those loads. Again, make sure you are wearing all proper PPE. That means selecting your PPE based on arc flash warning labels or NFPA 70E tables as appropriate. Always remember to follow safe work practices when opening and close your doors. Prepare your power logger test leads and connect to the correlating connections. Then, connect the flexi loops to the matching connections, making sure that all connections are correctly made. On the power logger, turn the dial to Power to begin the process of recording data. Press the Record Measure button to begin recording. Press Enter to accept the information on the warning screens. You can now observe data being recorded on your power logger. Once you identify the problem load, use the data you logged to support corrective action, such as sizing a capacitor. It's better to install a small capacitor at the load than a large one at the service entrance. So, if you want to create a win-win relationship with your clients, you need to educate them about power factor, you need to provide them a written report, and you need to recommend the installation of that power factor correction equipment to help save them money every month. For Fluke, I'm Randy Barnett.